Okay, in this video I'm going to be going over the Chapter 8 and 9 test review. The first one gives me an equation in standard form and it wants me to graph it and answer the following. I want to remember that when I'm given an equation in standard form, I need to remember my formula for my axis of symmetry, which is x equals negative b over 2a. Remember that the formula has a negative in it. So the first thing I want to do here is I want to identify my a, b, and c values. So my a is 1, my b is negative 6, and my c is negative 5. So I'm going to plug into that formula. I'm going to do it off to the side over here. I have x equals negative from the formula, negative 6 from my b value, over 2 times my a value of 1. So negative 6 is going to make that a positive 6. 2 times 1 is 2. 6 divided by 2 is 3. So that is my axis of symmetry, so x equals 3. It's also going to be the x value of my vertex. To find my y value of my vertex, I need to go ahead and plug into my original equation. So I have y squared equals 3 minus 6, 3 squared, minus 6 minus 5. So I'm going to go ahead and type that into my calculator. So I have 3 squared minus 6 times 3 minus 5, which gives me negative 14. I'm going to go ahead and graph this. It's just a little bit off my graph. So right there. I want to also graph my axis of symmetry. This is the line I'm going to be reflecting my points over. My y-intercept is my c value. Let's see if the screen's going to load. There we go. So my y-intercept is my c value. So that is going to be 0, negative 5. I'm going to go ahead and plot that point. And I can go ahead and reflect this over. So this one is 1, 2, 3 away from my dashed line. So I can go 3 away on the right side and plot that. My x-intercepts are going to come if I factor this. So I want to look for what multiplies to negative 5 and adds to negative 6. I don't know those ones, so I can go to my calculator and I can go negative 5. Divide by x. Then I go second table to see the list of values. Negative 5 and 1 give me negative 4. It's not a nice value, so I'll have to graph this on the calculator and see in a bit. So I need one more point to graph this. I'm going to plug in a number. I'm just going to pick one number to the right of my dashed line, so I'm going to plug in 4. Oops, I put the squared in the wrong spot. So I have y equals 4 squared minus 6 times 4 minus 5. So I'm going to go ahead and type that into my calculator. Which gets me negative 13. So I plot that, and then I reflect it 1 over. Then I want to connect my dots. You'll need 5 points on a graph in order to get credit on the test. Let's do my domain. It's going left and right forever, so my domain here is going to be negative infinity to positive infinity. My lowest y value is negative 14, and it can be negative 14, so I want to use the square brackets. It goes up forever, so we use infinity to represent up forever. My increasing interval, remember, is where I have a positive slope. So here on this graph is where I have a positive slope. Starting at this x value and going right forever. That x value, remember, is 3. And I'm going right forever, so that's infinity. My decreasing interval is where I have a negative slope. So that here on this graph is on the left side. So that starts on the left, and it ends at my x value of 3. This one is U-shaped, so that's going to be a minimum. If it's mountain-shaped, it's a maximum. And for our minimum, we always say it's our y value. So this is going to be negative 14. So I just want to highlight a few things. My y value should appear in the vertex, the range, and my max or min. My vertex, my x value of my vertex, is going to be my axis of symmetry, my increasing interval, and in my decreasing interval. So, last thing I want to do is find out where my x-intercepts are. Since this wasn't a nice one, I'm going to type it into my calculator. I have x squared minus 6x minus 5. I'm going to go ahead and graph this. And then I'm going to go ahead and go second graph. Nope, not second graph. Second trace. And I want to choose choice 2 for 0. Left bound means I want to be on the left side of my 0. So I'm going to press enter here. Then I'm going to cross the x-axis anywhere on the right side and press enter twice. And this one gets me negative 0.7. So negative 0.7 comma 0. And there's a second one on the right side. So I'm going to go second trace again. Choice 2 for 0. Arrow over. It says in the bottom. It's caught in the light. It says left bound. So that means I want to be on the left side of where it's crossing. Here I am. I press enter. Right bound. I want to cross the x-axis. Press enter. It wants me to guess. I press enter again. And this one gives me 6.7. So this one's going to be 6.7 comma 0. Okay, my next question says, given the graph, interpret the real world context. Assume x is time in seconds and y is height in feet. The graph represents the rocket being launched. Round all answers to the 10th place, so 1 decimal place. My y-intercept here is 10. That means the rocket launched from a height of 10 feet. My vertex is this point, 8 comma 74. So after 8 seconds, the rocket reached a maximum height of 74 feet. And then my zeros. This negative 0 doesn't mean anything. You can't have negative time. So this one is how long it takes for the rockets to land back on the ground. It takes, I want to meet around to the 10th place, so 1 decimal. 16.6 seconds. For the rocket to return to the ground. Okay. On the back side is just more of the same. So I want to go ahead and do the same thing. I want to remember my formula for my vertex. So that's x equals negative b over 2a. I want to identify my a, b, and c here. My a is negative 1, my b is 8, and my c is negative 7. So plugging into that formula, I get x equals negative 8 over 2 times negative 1. This 8 is negative because the formula has a negative and that 8 was positive. So negative 8 over negative 2 is positive 4. My axis of symmetry is x equals 4, and it's also the x value of my vertex. Then I want to go ahead and plug into my formula to find what my y value here is going to be. When I plug this in, I want the negative outside of the parentheses. So I have negative parentheses 4 squared minus 8 times 4 minus 7. This gets me negative 55. So this one is way off my graph. I'm going to change my counting. No. Yeah, I'm going to change my counting by, I'm going to change all of these. So that's going to be negative 10, negative 20, negative 30, negative 40, negative 50. So that's going to be 10, 20, 30, 40, 50. So now it's just a little bit off my graph. And then next part is to find my y-intercept. That's always my c-value, so it's going to be 0, negative 7. So since I changed my scale, I need to remember to adjust that when I go to graph this. Then I want to, that one's 4 away on the left, so I'm going to reflect this 4 away on the right. Let's see if I can factor this one nicely. So first thing I want to do in order to factor this is I want to take out the negative. So this one, I'm looking for what multiplies to positive 7 and adds up to negative 8. It's negative 7 and negative 1. I'm going to write it down here. So I have negative x minus 7, x minus 1 equals 0. Then I want to take each of those factors by the zero product property and set them equal to 0. I get x equals 7 and x equals 1. So it's 1, 0 and 7, 0. My domain for all of my quadratics is always the same. It's always negative infinity to positive infinity. I want to go ahead and graph my y-intercepts. My x-intercepts, I meant. Hold on. I think I typed this into the calculator wrong. Oh, it should have been plus 8. Yeah, so that would have given me 9 thing. Okay, so I'm going to grab a new graph. I did this all wrong. What I want to do instead is, I still have my axis of symmetry at 4. This point is at 9. My y-intercept was at negative 7. And my x-intercepts were at 1 and 7. So I can reflect my y-intercept over. That was 4 away. So 4 away right here. Then I connect this like this. My range, it goes down forever, so I start off with negative infinity, and my highest point is 9. My increasing interval is where, remember, I have a positive slope. So on this one, it's actually flipped. It's on the left side. So this is negative infinity to that x value of 4. And then my decreasing interval is where I have a negative slope. So this is from 4, and then it goes right forever. My shape on this one is mountain shape, so it's a maximum, and the maximum is always my y value. So these numbers should always be the same. And then my x values for my vertex, axis of symmetry, and increasing and decreasing intervals should always be the same. Okay. Next one again is a graph, and it's another rocket. This one wants me to state and interpret the following. So my y-intercept, it starts at a height of 42 feet. My vertex is 11,163. So after 11 seconds, the rocket reaches a maximum height of 163 feet. My zeros are where it's crossing the x-axis. Negative zeros don't mean anything. I can't go back in time. So after 23.8 seconds, the rocket returns to the ground.